Hello there folks, well, we've got a Danita 301. Somebody's emailed me and they said, what do I know about the Realistic 1013? The answer is nothing. We've got one kicking around somewhere. Goodness knows what box it's in and which storage facility it's in, but we've got one somewhere because I bought it new. Not that enthralled because you've lost the metal case, and by losing the metal case you've lost a lot of range. Are they 9 volts these? So this is a CPT set, whereas the Realistic is a UK 2781 set. I think they're AAAs as well, aren't they? No, the double A's. So it's going to be 9 volts if it's on normal batteries. We bought 3 of these at a radio rally. So Danita 3001. I've never seen inside one. So what I've got up, down, it's going to be a transmit, busy light, high low power. It's got a BNC on the top, so that gives us access to the outside world without any faff. That's good. I like that. We'll do a field test on this as well. We've got 3, so we're going to be able to get 1 to work, aren't we? Yes, Mr. Tango. So our person who's contacted us, he's got a dead set. Now, of course, if somebody's 12 volted it, because it's 9 volts, or even worse, 13.8 volted it, they will kill it. So it is 9 volts. And it quite clearly says it's positive centre. And is it 1.3 millimetre or something? It's like more like a Walkman. Certainly isn't going to fit our ones. That's going to be fun, isn't it? Whether or not we've got anything we can solder up to make up a lead is another matter. So I think we're going to start off by opening this up. Now to help him, because I was able to download the destruction book, and what does it do? Interesting. At 13.8 volts, it's 3 watts and 1 watt. So you can apply 13.8 volts. So our thought there is out of the window. At 7.2 volts, which is what you'd get off rechargeable batteries, it's going to be 0.8 watt and 0.2 watt. So 9 volts, which is what you'd be getting from throwaway batteries, it's anybody's guess. So power, 9 to 14 volts. There we go. See what you learn. Anyway, he's got a dead set. So we've got the power input from the squocket, protection diode, choke, on and off switch, 3 transistors. It's like KTA2504, 2SA473 and KTC3475 by the looks of that. Obviously that's a scan of a blow up of a scan. Regulator there looks like 5.1. Is it any clearer on this diagram? No, it's less clear. Unlike that, it is a different diagram. So there we go. So it can apply more volts than I thought. So get it out. I doubt this is going to be faulty, but it needs to be shown, it needs to have a tune-up. So it doesn't look like it's had batteries in it. So the only difference is probably going to be the synthesizer and of course the approval between this and the Realistic. Well, that's got some screws out. I've no idea whether we're taking the front or the back off. Front. My dad, my late father, fancied himself as a clock repairer one day, and he took a clock apart. My late mother told me, and he took the back off this clock, and all the bits and pieces fell out. So my mother took it to a clock repairer's, and in a bag with all the bits, and the chap behind the counter says, "Has your husband had a go at this then?" My mother says, yeah, it looks like he's took the back off, you take the front off these. Wow, we got there. Oh, it's the annoying chip which starts on channel 9. So electric condenser mic, epoxy little speaker, several layers of boards. We're going to be able to adjust the frequency, that's one good thing. That's going to be VCO, isn't it, because it's there. And I don't expect you can get to anything else, because you need a jig. We've got a preset there. I bet that's going to be deviation because it's near the synthesizer, which is where it's going to have to apply the audio. Screening plate. So is it possible to take this bit off? Yeah, it is. Oh, take the whole lot off, front and back. Oh, yeah, you can do some tuning. Wow. Well, that's better than I thought. I have to take that off to do the tuning. There we go, so pretty conventional this side. You can see we've got T2 there, so at least it's giving me T1, T2, T3. That's the PA, just check that's tight, it is. Driver transistor, output transistor, transpires detector, it's crystal filtered on receive. Of course it's all surface mount, isn't it? So, well, a lot of it's surface mount. So how do we get to that? Oh, it's got a hole through the board. Well done. That's going to be deviation. Those wires just aren't quite long enough to have it the way round I'd like to have had it round. We can connect it to our test gear with crocodile clips like we do. Quick look at the circuit if I can see any of it. It's the trouble when it's a copy of a scan. What I'm looking for is if I can find a preset other than deviation. Looks like low power's preset because there's a resistor there and a switch there. So I was wondering whether one of those was variable power for that, but it doesn't look like that's the case. But at least we've got a circuit diagram which is better than nothing. I can't see any other presets. I mean, they've got to be there, but the circuit diagram's not that good, as you can see. I mean, I was thinking possibly along the lines of the other preset being squelch. Aha. Well, we've got I mean, that looks like it says vol. I can't think that it could be, because that's going to be there wherever I found it and lost it again. Oh yeah, here we go. Here's the audio. Well, it's going to be fiddle and find out, isn't it? Well, I was hoping to discover T1, T2, T3, T4. They're all receiver. So this is receiver. So I'm looking now, perhaps 7 and 8. 6, 7 and 8 could be transmitter. Eight certainly is. 7. Looks like 7, 8, 9. 1, 2, 3, 4. And certainly 6 is the detector. So it's what? 8, 7. VCO is going to be there, so we're not going to upset anything. So I think we've got the front end here. I think we've got the IF detector there and there. and that takes us to 6. 6 is the detector there, and then those 3 is going to be the transmitter. 6, 7, 8. 6, 7, 8. Right, crocodile clips. Power supply on, and initially I'll run this at 9 volts just as a test. Power on. Because if I turn this over, we'll probably lose the connection. Because it's booted up on channel 9. That's what's going to happen. It's going to keep changing its mind, isn't it? So we can easily connect to it. At least that's one thing. Just get the BNC adapter, which is exactly where it should be, not. Now, we've got no earphone socket on this, so we're going to have to take the insulation thing, bend that back a bit, so we can get onto the speaker pad. Let's make sure we've got 2779125 on the signal generator. Oh, cool, it's 27205, isn't it? Yeah. CPT. I've had these about 4 or 5 years, just not got onto them because I thought, oh no, what a pain. No information, but at least I've found some information. Right, let's see if we can hear anything. Squelch works. Well, I've got absolutely nothing coming through. Let's go into transmit. Let's put picture in picture on, it's on. And what meter are we on? Well, put a camera 1 on. $27,165. What channel are we on? We're not on 20 anymore, are we? Now the power's gone off, so it'll be back to 9. Oh, I love these type of things. Okay. So, at 9 volts, we have got 1.4 watts. So, we're going to have to unpower it, repower it. 13.8 volts. Pop it back to 20. See what the power is. I'm not going to, normally, you know, I do the different channels. It's so awkward to be changing channels. We'll do everything on channel 20. So it's doing 3.5 watts. And what did they say? 3 watts. So was that low power, that switch? Or is that instant channel 9? Channel 9, isn't it? High, low power's on the top. And on low power, switch to low power on the thing, it is doing 600 milliwatts. It'd be nice if that was what the other preset was. So deviation on here, while we're in low power, may as well do deviation. I'll have to reset the meter. Wallow, wallow, wallow. It's reading 1.8 on here. So I'll tell you what we'll do. We'll go over to the other test set right away. And we'll do the deviation. Wallow. It's about 1.8. What we're going to do, I think we'll go back to the Marconi test set. We'll use the oscillator. And then we can do the deviation. So that's obviously going to be deviation. So keying it up. Wallow. Let's try and get that mic over that. So it's quite low because it's going to be, isn't it, folks? Yes. Wallow. Wallow. Now, according to this test set, I'll just turn this volume down. That is 2.2. So we'll go back over to the other test set just to verify. We could use 3 test sets and have best of 3. Wallow, wallow. It's 2.2. So the Marconi set's right today. Right, we'll turn that off. So it was 1.8. I better thought I'm not having these. They're blooming quiet. Well, that's probably the hardest adjustment we're going to have to make on these. Danita 301. At 13.8 volts. We said 3.5 watts. That's over the top. Right. Let's go back to full power. .04. It's a lot of power from your double A's, isn't it? This is what the problem is. You know, if you turn these up, if you turn up any walkie-talkies, certainly be one 3.5 watts, you're going to thrash the batteries. The newer they are, the worse they are. This is drawing more current than those big 1001 and 1005 sets. Right, let's see if we can dare turn it round. Go through this transmitter. So we're now back on full power. Let's just run through this. Peak. Peak. Yeah, it's 3.5. I'll just see if this preset, I think that preset's going to be squelch. I'll tell you what, let's put a signal on. Have we gone back to channel? No. Just do that again because we're actually on channel 39, because you're putting it down on the channel change buttons. So we'll do the frequency. So let's have it see what it is at the moment. 20471. Let's bring that up to the correct. I'm going to put it back on low power. I'm not wanting to heat this thing up more than necessary. It's going round in circles, isn't it? $27,205. It was 1.8 kilohertz deviation. It's now 2.2 kilohertz. There we go. It's too good to be true. Change channel. Wouldn't it be nice if they could hold the memory of what channel they were on for 10 seconds? So I want to just fiddle with the squelch. So at the moment, full squelch. Is 3 millivolts. Just see whether turning that preset affects the squelch. Subject to. Are we back to having to use a screwdriver on that one? Try another proper tool. Yeah, it is squelch. Right, so we know that's squelch, so that was a good educated guess. So as far as transmitted done, we've done the deviation, we've done the frequency, we've done the power. We can write that down because it's still 3.5 watts. Let's go back to the power meter, just get that out of our hair. So that's low power. Let's tell you what low power is. And I think I'm changing channel here. I am. I'll take these knobs off to stop this happening. Right, I'll hold the radio and key it up. And we're here on low power. So let's get this right. If that was 30, which is it's 600 milliwatts. Full power. Switch over to full power, and it's 3.5 watts. So it's still the same, and we said it was 600 milliwatts. I was just when doing the power, it was already peaked. I've just skirted around the edges, made sure it's peaked. That's where it is. So we've done that. We're not going to do the VCO. We haven't got a method for that. No meter. Right, we'll move on to the receiver. I've gone and disconnected it. to do the on-the-air test, we're going to have to find something that fits, aren't we? Because I can't be holding it like this. Right, so turn the squelch down. That's volume. Turn the squelch down. We've got to now get the SINAD meter somehow. Change channel. I'll take the knobs off and see whether that helps. You'd want to jig, wouldn't you, if you were doing these? So, we need to... It's changed channel. I'll just let it stay sideways for now. Well, that was not as hard as I thought. So put the test gear on. Let's get a reading. .37. For 10 dB, 0.31. For 20 dB, 0.66. Squelch threshold. Switch signal generator back on. Well, that's a bit harsh. 2.8. But then it's too high, isn't it? 2.8 microvolts. That wouldn't be good round scratchy corner. It'd be just a scratchy corner. Right. So we'll turn the squelch back down. I better kind of hold this so that it doesn't get channel changed. Just put a little bit more volume on. Go to the oscilloscope. Check the detectors where it should be. The answer was not quite, but not far out. So, go over to the SINAD meter. Did I just turn that one, or did I turn that one? That's spot on right. You know what? This is well set up. Tiny little bit on that one. So we'll just go back to where we started on the oscilloscope, because the detector's that one, isn't it? No, it's not. So that is the detector. So that must be IF. So we'll go back to the SINAD meter. Let's get a new reading. I'll put it down. bearing in mind I've done the detector, 0.38, skirting around the edges again. .32, 10 dB, sorry 20, .66, so just skirting around the edges. So it was absolutely spot on receive. It was absolutely spot on transmit. The only thing we've done is putting it on frequency and turning up the deviation. Now the squelch does need attending to. So put the squelch to full. God, I wish all radios came set up like this. Right, so I'll put 100 microvolts on, and we want to twiddle the preset here until we get it coming through, which we have. That's actually now too slack. That's it, 100 microvolts. So now, just show you on the thing, 1, 3, 10, 30, 100. So now we'll do the opposite, park it at 0.3, turn the squelch down. Set the squelch. Switch the signal generator back on. .8 is not good. Best you can get. Well, 1.8, I want them always to be under 1. So I wonder if we really carefully set this. That's really on the edge, and switch back on. Yeah, about 1.7 is all you could get. I'm just checking the IF there, using the squelch as the guide. Just once again check the detector, because that affects. Turn the volume up. We've now got 1.7 by really manipulating that. So 1.7, just check I haven't affected the sensitivity. .12 dB, 0.38, it's exactly the same. Right, we'll turn that off. Turn this off and attempt to put it back together. So all I've got to do, he says, is see if we can find a tiny little socket, plug that goes into the input socket. Alright, I may as well pause the video while I put this together. A couple of hours later, we're back together. Take picture off. Had I anything to fit in these holes? No. But I remembered there was a box of junk and there was a Nokia phone charge. I don't even have a mobile phone, but one of our club members, Len, G4 whatever his call sign is, brought a box of junk, and in there I remember there was a Nokia phone charger, and I also remembered it's got a small squawkit on it, it's plug, and as luck would have it, it fits. So put in the comments how many millimetre that is. Is it 1.7, 1.3? Absolutely no idea. So we are on power supply 13.8 volts. We will connect this to, got to be able to get 1.5 amps through this on transmit. That sounds fanciful. So we'll connect that to our crocodile clips. Black is negative, we've checked. And white is centre positive, we've checked. That is a whole lot of nothing. It's positive. It's possible that that's not long enough to reach down the barrel. How frustrating. There's a bit of wire there off a component lead. We'll poke that down there. Yeah, well, if it's open circuit. No, it isn't. Yeah, if you really hold it in, it makes contact. The barrel's not long enough. Well, I could do an on-the-air test holding it in. There's always something, isn't there? Can I just remove that lip? Yes, I can. Go to the top of the class and jump off. Right, roof aerial. One and a Roger. One and a Roger. So it doesn't go red, it stays green. I wasn't expecting that. So if we turn the squelch so we've got no hiss, press transmit, it's green. Oh, there we go. Oh, of course it's CPT, no wonder there's nobody on it. What am I like? Well, the way it's been set was absolutely faultless. Other than... This is 1.46. The snag being... deviation was stupidly low, and it was slightly off frequency simply because of age. But amazingly well set up. With 3 of these, I'll have to do the other 2 up and put them on eBay. Right, well, thank you for watching Danita 301, and I hope that's helped people with Realistic 1013s, because it's going to be exactly the same radio but with a different phase lock loop processor chip there.